Hello, CIS40A. In this video, I'm going to talk about wireless networks, which is in Chapter 10 for CIS40A. And to begin, we will define wireless LANs, which is wireless local area network. And in this type of network, we would use radio frequency to be able to transmit signal across different part of your network, which is physical locations. And that your wireless adapters would use radio waves or radio frequency in order to send. And these waves can be absorbed, refracted, or reflected by walls, water, metal surfaces, or low signal strength. So in the case where sometimes you would see that there's signal degradation is because if there's water present like a fountain or glass, or some kind of wall or metal plated wall also do that. So this is why when you go into facilities, sometimes you would see that they install specific glass wall or water fountains or things to really divide or shield the signal from leaving a certain area. So then you would see that sometime we would be able to transmit greater distance, and sometimes we would have degradation in signal. And a lot of it is depending on our antenna. So the wireless technology that we're using is incorporated with different types of antenna. Omnidirectional antennas send radio signal in all directions, 360 degrees, to cover all the broad range or the area in all directions. Semi-directional antenna sends radio signal in a single direction, and that will only cover a wide range in a certain direction of the device. So we would install or use a certain type of antenna in a certain location. If you have a device that have omnidirectional antenna, this is where you would use to be able to send signal in all direction, like down the hallway in your facility. So everybody, as they walk through the hallway, they'll be able to receive signal. But in a section where you want only a certain spot to have signal, you would use semi-directional antenna and not send signal to the rest, like emergency room, where the doctor's center in the center location, you would have some kind of Wi-Fi AP, and that would have semi-directional antenna. But going beyond that point, you don't want that signal to be crossing with other type of machinery that uses radio waves. So then next is we're going to talk about wireless agency and standards. So you have IEEE. This organization maintains operational standards for Wi-Fi and other technology. FCC regulates the use of wireless devices in the United States, whether it's safe and it's up to standard. In Europe, European Telecommunications Standard Institute, your ETSI, is chartered to produce common standard for European countries. Wi-Fi Alliance promotes and tests for WLAN interoperability. So not all the devices are tested. However, Wi-Fi Alliance allows company to be able to test so that way it will work across different brands, different type of interfaces, and so on. WLAN associations, or WLANA, this is an entity that educates and raises consumer awareness about WLANs. So for United States and North America, FCC released 3 unlicensed bands for public use: 900 megahertz, 2.4 gigahertz, and 5 gigahertz. So for your home network, you often see 2.4 gigahertz and 5 gigahertz. 900 megahertz were used in the old telephone network. This is where you often see with cordless phone. And these bands are referred to as industrial, scientific, medical ISM bands. An ISM band was established in 1990. It was deployed and used today. So when you're looking at mesh network, office buildings, healthcare facilities, warehouses, homes, businesses, you would see ISM exist everywhere. 5G is a band that's known as Unlicensed National Information Infrastructure, or your UNII band. And so when you're looking at the spectrum for these bands, if you're looking at AM broadcast radio compared to FM broadcast radio, the 900 megahertz band operates within the FM broadcast range. So when you're listening to your car radio, that is the 900 megahertz band that you're using. When you're using your cellular network, that is on 840 megahertz, but now we're using mostly a digital network instead of the cellular network like what we've seen in the 90s. So we would be using your 5G network in a sense where it is in higher frequency. But for your home network, when you're using devices like your TV and your other IoT devices, we're using 2.4 gigahertz band. X-ray radio frequency is higher compared to wireless, and as you can see there on the spectrum. So on the newer edition, what you see is that we would have different standards that are being developed for different range in the bands. So in wireless history, what you see is radio and the speed for that and how data is transmitted, and then transitioning to what you see on Wi-Fi and now 5G. So we transition from the 802.11, ABGN, and now AC going into AD. In the cellular network, we would have GSM, which stands for Global System Mobile. This is used for a cell phone that contains subscriber identity or your SIM chip. So when you subscribe to a provider that uses SIM, they use GSM, such as AT&T and T-Mobile. Fdma, frequency division multiple access, is a modulation technique used for a cellular wireless network. It provides frequency range into bands and assign band to each subscriber. This was used in 1G cellular network. TDMA increases the speed after FDMA, and that is just dividing the channel into time slots, which prevents eavesdropping. And then we have code division multi-access, your CDMA, uses unique code for each of the call transmission. And then long-term evolution, your LTE, is the standard for wireless broadband communication for mobile devices and data terminal, which is what you've seen on a lot of the mobile networks now, like T-Mobile. So GSM Edge and your UMTS were the prior technologies transitioning to LTE. So for the first few questions, we can say that number one, explain the relationship between frequency and distance for the wireless network. So when you're using 5G, just keep in mind that when your signal is in higher frequency, you're transmitting in shorter distance. When you're using 2.4 gigahertz, it's going to go further in that it's using lower frequency and the signal is transmitted in larger distance. And so there is an indirect relationship between frequency and distance. For number two, in what type of facility is ISM band used? In many facilities, office buildings, healthcare facility, warehouses, business, homes, or even cars. What type of cellular network uses 5G? We can say that code division multiple access, your CDMA. This is where it uses a unique code for each call or transmission, and it's going to spread across the spectrum, allowing the call to use all frequency. Long-term evolution, LTE, is a standard that uses broadband communication for mobile devices and data terminal. And this is for GSM Edge and UMTS HSPA technologies. Depending on the type of provider, some provider uses a specific type of cellular network. So now let's take a look at 802.11 standards. So here provides you with the table for different type of standards. We start with 802.11a. The purpose for this was to use higher frequency, 5 gigahertz. And the transmission was only 54 megabit per second then. This was an older standard. 802.11ac, which is what we're currently using, we're transmitting at 1 gigabit per second or higher, and we're using 5 gigahertz frequency. 802.11b is an enhancement of 802.11a, and this was transmitting at 5.5 megabit per second to 11 megabit per second, and this was in early 2000. 802.11c was used for bridge procedure, same thing with D, E, F, and then later on, after the B, they released 802.11g, which transmit at 54 megabit per second, the same speed as A, so it is the updated from A. It uses 2.4 gigahertz standard. It is compatible with 802.11b. So if you have 802.11b wireless router, you can use 802.11g devices, but in that it would only access the router, or the router transmit at the speed, maximum speed, which is going to be 5.5 to 11 megabit per second. After the G, we have 802.11n, which was an improvement, and it uses MIMO antenna for multiple input and multiple output, and it also improved encryption. So here lists all the standards that you see, and it gives you the description. So in 802.11b, this was created with carrier sense multiple access with collision avoidance, your CIS40A. This was implemented for request to send and request to clear, your RTS and CTS. So that way the host must communicate in order to send. So the source would then send an RTS, the destination would receive that and clear it, then data would be transmitted, and then the target system would acknowledge. In 802.11g, this was implemented in 2003. It was backward compatible with 802.11b. It transmit at much higher rate compared to B, and it uses a 2.4 gigahertz range. So the channel that was supported, what you see here is when you're using 2.4 gigahertz, there are some overlapping channel, and then there are some specific channels. So in United States, there are 11 channels that are configurable. 1, 6, 11 are non-overlapping. That's what you see in the dark circle. And what you would see is that the other channels are overlapping. So if you configure your access point on channel 1, the next access point needs to be configured on 11 or 6. On 5G, 5 gigahertz frequency, 802.11a was operating then. So operating at 5 gigahertz radio band 802.11a was immune to interference. However, we were able to get higher speed, but it's distance-wise, it's not going to be as good as the other band, the other standards. So in the next part, it talks about the other frequency and the other standards, 802.11n, along with having implemented MIMO, as we talked about in the assignment, and 802.11 protocol requirement acknowledgement. Each and every frame that 802.11n can pass many packets before an acknowledgement is required, so it's able to save the time by just reducing the amount of acknowledgement that it needs to send. So Wi-Fi is known as wireless fidelity, and in that there are requirements for interoperability across the standards, and this is managed by the Wi-Fi Alliance. 802.11ac is our current standard, and that works with 5 gigahertz range, delivering up to 1 gigabit of throughput as far as speed. Now, most of your devices at home actually uses the lower range, which is the 2.4 gigahertz range, compared to the newer devices. Some of them use 5 gigahertz range. So if your laptop is able to connect to your access point or your wireless router using 5G or 2.4 gigahertz, keep in mind that 5G, even though you have higher throughput as far as transfer rate, you are going to be limited to the distance, the physical distance from that access point or that wireless router to the laptop itself. Most of your mobile devices like TV, tablet, and so on function best on the 2.4 gigahertz, as if we were thinking that distance is an area that we need to address. So here it gives you the scope on 802.11b, G, A, and so on, and the physical distance. So the maximum capability when we're looking at G was up to 300 feet. And the further you go, of course, the lower the transfer rate. Compared to A and B, when you're using B, 802.11b, you can go up to 350 feet. Remember that it is 2.4 gigahertz, in that you are only transmitting at 1 megabit per second. In 802.11a, since it's using 5 gigahertz and it's able to transfer at 54 megabit per second under 100 feet. So the farther you go, the lower the transfer rate that would be. So at close to 200 feet, the maximum that you will be able to transfer with 802.11a is 60 megabit per second. And the same would apply in what you would see with AC. So now when you're looking at AC, since the technology has changed since then, we were looking at wireless access point, connects all the wireless devices together, and that can be incorporated in as a router, but where you cannot have an access point becoming a router, but a router can be an access point. This is what would your wireless network adapter look like if you need to install an adapter if it's not built into your laptop or your system. And again, it talks about omnidirectional, and you can have semi-directional or point to multi-point directional. What you see in the old TV cable antenna that would be Yagi, and Yagi antennas are much greater range than Omni antennas, and so it focuses on the power in a single direction. Therefore, it's only going to be a point-to-point bridging for access point. And you often see this on roof of businesses or people's home. When you're installing a wireless network, you would see there are two types of installation. One is going to be ad hoc and the other is infrastructure. And in the ad hoc environment, that will be the easiest, where all the devices are seen as equivalent in the role. You would use an access point. You can have two laptops, multiple mobile devices to be able to add them to ad hoc node. And for the network settings in the protocol, they are enabled to be able to transfer file or share resources. We can call this independent basic service set, which is created when two wireless devices communicate, where two laptops are transmitting data. And so a diagram for this would be something like this. Assuming that all of them have the network adapter, wireless network adapter, and they are within 100 meters from each other. The infrastructure mode, this is called the basic service set, or your BSS. This is allowing wireless to be operating in the infrastructure mode, in that network interface can communicate only with the access point instead of directly to other devices. So it has to go through the middleman, which is the access point, in order to communicate with others. All communication between hosts, including the wired portion of the host, must go through the access point. So therefore, in basic service set, it's different than the independent basic service set, in that the access point becomes a centralized management controller. Now, if we add that access point to our network environment, we can include that in the distributed system, in that we will be able to bridge it through our switch and then our router, and our router would then be connected to the internet and the server. So then your access point will be able to advertise its SSID, which is Service Set Identifier. This is a unique 32-character identifier that represents the wireless network. And this can also be turned off in the configuration. Now, when you have the same SSID, the mobile wireless can roam freely in the same network, where you are creating an extension of that access point, where you would extend, and you want to overlap by 20%, like what the diagram is showing. So we would have here one access point using channel 1, and the second will be channel 6. The overlapping in the signal will be 20%. So as you have degradation in signal right here at the edge, you want to have the proximity in distance, in that it will be overlapping by 20%. So when somebody uses the system and travel down the aisles or the path, what you would see is that we will never lose signal. So when you have an extension like that, this is called the ESS, or extended service set. We can also implement what's called the controller, or the wireless controller. And as you saw some of this in the lab for last week or this week, we saw that there's dynamic controller with Cisco wireless devices. So what we can do is we can configure a specific access point, and we will be able to split the duties across, so that way the controller would then manage all the access points. So in a standalone solution, you have separate access point. The administrator will configure it, or you can configure the wireless LAN controller, and it will be able to manage all the access points. So then your administration will be a centralized area. It will be manageable, And so that way, if you need to modify, you would just use this device in order to modify the rest. So let's go to the question. For number 4, it asks you which wireless IEEE 802.11 standard has higher rate of 11 megabit per second and that was widely adopted. That was 802.11b. For number 5, which wireless 802.11 standard has transfer rate of 54 megabit per second is backward compatible with 802.11b? That will be 802.11g. For number 6, how many channels are configurable in the United States and what are they? There are 11 channels that are configurable in the United States because we are overlapping in 2.4 gigahertz frequency 1, 6, and 11. Channel 2 through 5, 7 through 10, and 12 through 16 are not overlapping. Number 7, Teresa configures an access point to use channel 1 in the building. If she needs to add another access point in the same building, what channel could she use in 802.11g standard? She could use channel 11 because 1 has already been used. And 11 is the farthest from 1. She should not use 6 because 6 is closer to 1. Question 8. What are the benefits of dynamic frequency selection, DFS, in the wireless network? It prevents interference in the occurrence of the WLAN. So let's touch on some of the section here. In the notes, it talks about what a mobile hotspot is and signal degradation. This is important. So the farther you are from the wireless access point, of course, the less of the signal that you would be receiving. The maximum would be equal or less than 100 meters for most systems. If you put walls or barriers, that also reduce signal. It interrupts the signal as it would bounce off the wall. And so the range of the network could only be as low as 25 feet. So when we consider that, we want to be able to relay that signal by using additional extension to our access point. Your interference could be caused from other systems, and so other systems, if they're performing at 900 megahertz, 2.4 gigahertz, or 5 gigahertz ranges, will interfere with your sources. And there are many devices that are using radio frequency. So we have to determine what kind of frequency those devices are using and are they interfering with the wireless signal. In the Internet of Things, we have Z-Wave, ANT+, Bluetooth, NFC, IR, and RFID being used for wireless devices. Z-Wave is a wireless protocol that's used for home automation. This can be added to the mesh network. It is low energy radio wave that can communicate appliance to appliance. This can be used in residential, such as for lighting control, security system, thermostat, windows lock, swimming pool, garage door openers, and so on. ANT Plus or ANT Plus is another wireless protocol that's used for monitoring sensor data, such as people's heart rate, bicycle tire pressure, and this is often implemented in your wearable devices. Bluetooth is then used in wireless adapter or as an adapter. It is in shorter range and it does add devices as ad hoc. NFC is a near field communication. This is implemented in your phone along with the Bluetooth. And Bluetooth uses 802.5 instead of 802.11. So Bluetooth is made to be paired one-to-one device, where NFC can also be used one-to-one device where you can use it to be able to pay in transaction when you're using Google Pay or Apple Pay with tap, or when you are using your device to control your appliances or your TV. through an app. IR is for infrared, and this is used for a lot of different things along with door opening or door security system. RFID is used for asset tracking. It uses RFID tag. You often see this with products in stores. So to configure wireless LAN, you would need to have a wireless router. You can set up your SSID and the default IP address of that wireless router. If it's not specified, it's 802, it's 192.168.0.1, or sometime it will be 192.168.10.1. You would need to open up your browser and be able to access that. Use the login in order to set up your new account and your password, and then you can set up wireless channel. With that, we can set up how encryption would be used for authentication. And so therefore, it's important to really think about WPA2 as the latest encryption that would be protecting your authentication. Compared to web or WPA, WPA2 is much better. So when we set up wireless in a network, we need to do site survey. And basically, you just need to gather the information on how your signal is going to be transmitted, what kind of application and data types that you're using in your network, and the areas, the distance, the range that will be covered, and the type of wireless devices that will be supported, like your laptop, your iPads, your devices in general. So there are two types of site survey. There's a pre-deployment survey and there's a site survey that's post-deployment. So the pre-deployment surveys, we would need to look at your access point, the location, the placement, how it's going to be able to transmit signal. After you install those, then you would do a post-deployment site survey. This will confirm the design and the placement. Otherwise, we have to move a certain access point so that way we would have overlapping coverage. And lastly, we want to touch on the capacity. When you place your wireless stations, we would want to have overlapping, as the circle is shown, with the 20% overlap for each one. So what you would do is simple. You can use a wireless device like your mobile phone in order to read the signal, as you would look at the environment of where your access points are placed in a facility. So now, when we go back here, question 8 asks for the benefit of dynamic frequency selection, your DFS, in a wireless network. That allows us to prevent interference from occurring in the WLAN. For number 9, the benefit of transmitting power control, TCP, over the wireless network. TCP enables the client to access to and the access point to communicate with less power, requiring client machine to use just enough power to preserve the connection to the access point and conserve the battery power, plus produce interference for the neighboring WLAN cells. You see this in industrial systems, in that it would use solar panel in order to charge and then be able to use the power to be able to generate signal. So, and you would see this in city like City of Riverside, Loma Linda, where you drive around town and you would see these wireless access point being installed near the light pole, and it would have a self-charging type of equipment that will be attached to it. For number 10, the purpose of multi-input, multi-output MIMO. This is integrated with some of the newer technology, where it would be able to use multiple transmitter and receiver antennas to increase the data throughput. So we would be able to have more data throughput using MIMO. So when you buy devices, make sure you read the description to see if it's providing MIMO. Number 11, Carlos bought a new wireless router and found Wi-Fi sticker on the box. What does the sticker imply? That the router basically passed certification testing for 802.11 interoperability for Wi-Fi Alliance. It's been tested, but keep in mind that not all manufacturers have tested their device. So this is a nonprofit group that is formed to ensure that your standards are going to work across different type of technology, different manufacturer, and it would communicate seamlessly. So you can buy a network interface card from one brand and that will work with another brand and so on. And the testing validates that. For number 12, what is the transfer rate for 802.11 AC wireless devices? That will be 1 gigabit per second. For 13, Paula wants to upgrade her wireless network speed. She purchased a new 802.11 AC wireless router. In her home network, she's using 2 laptops that have 802.11n wireless adapter. What is Paula's system maximum transfer rate? How can she improve transfer rate in her wireless network? So the maximum transfer rate for her laptop, because it's using 802.11n, it will go up to 450 megabit per second with antenna, and without antenna, the laptop is transmitting at 300 megabit per second because it's using 802.11n, sometimes less. To upgrade the network transfer rate, Paula would then need to upgrade laptop wireless adapter to 802.11 AC, so when it's on the same standard, she can then use the laptop with the transfer rate of 1 gigabit per second. 14. Mac's office is 200 feet from the company's 802.11g access point. Why is Mac's laptop transfer rate 15 megabit per second, much lower than the rated transfer speed? Because there's degrading in signal due to distance. So to fix this problem, you would then need to consider adding another access point so that way his office would be able to get full signal. And the second access point, that will be an extension of the first. It uses ESS as what we talked about with the extended access point. 15. In wireless network, what type of devices connect all components together, and that will be your access point or your wireless access point. And compare that to a wireless router. The wireless router can function as an access point, but an access point cannot route. It does not use interchangeably. Number 16, what type of antenna is used in an access point? Most of the time, we would use omni antenna. Now, in the case where, like I mentioned, if you have an access point that you only want to transmit in a certain corner or a certain direction, you would use semi-directional antenna. For 17, what type of antenna is used to connect two access point? You would use the Yagi antenna that will be point to point. Number 18, provide an example of an ad hoc network. How would you install this type of network? You have two computers connecting wirelessly using wireless adapter, or you can install wireless adapter and configure the ad hoc settings on a specific system. So when you connect computer to computer wirelessly through the adapter, that will be an ad hoc network. If you're using an infrastructure network, that will be an infrastructure mode, that will be through the access point, where the system would see another system through the access point. Number 19, Mark is installing a wireless network for a small business. Consists of an AP, small business server, laptops, wireless printer. What type of wireless network is Mark installing? And this would be an infrastructure mode, as we would use the access point in order to connect all the systems together. And the system will communicate through the access point. Number 20, to ensure that the user is able to access wireless signal, what is the recommendation when installing multiple access points inside a network? All access points should be overlapping with the signal of 10% or higher. Sometimes 20% is recommended. using overlapping channel like 1, 6, and 11 on each of the access point. Number 21, what is the difference between the wireless standalone and control-based wireless network? How are they configured? So the standalone controller does not have the full operating system. They're managed independently and individually controlled. The control-based system has full operating system. Controller is configured to manage all other access points. Number 22, what are the impacting factors of wireless signal degradation? Distance, walls, protocol limitations, and interference. So we want to check out how far it is from the source to the destination, the access point to the device. Are there walls? What kind of protocols are being used for wireless? As we have different type of protocols, and 802.11 standard is only one. And if there are other type of system that's using radio frequency. For 23, before installing a wireless network, what should you consider doing when doing a site survey? You need to look at your network scope. How big or small is your network? What type of network devices are you using? So if you're using a lot of IoT devices, then you can plan on the type of wireless network you would have, how many access points, and how you would connect them to the backbone. And the compatibility, and are they compatible as far as standard? What kind of protocols are they using? What is the expected capacity? And looking at data and application needs for that wireless network and the throughput. And so this concludes my lecture for Unit 10 for CIS40A. Thank you for watching the video.